Hi, in this video, we are discussing the question number 7 from the exercise for the chapter Laws of Motion, which is the fourth chapter for the 11th standard physics syllabus. Now, in this question, we are dealing with a system made up of 10 identical masses and 10 strings, such that they are arranged one after another in a linear fashion like this. Now, as per the question, this topmost part of the top string is not at rest. In fact, it is under an upward acceleration which is given to us in the question. And because of this, I can say that the entire system must be under an upward acceleration which is same as this acceleration. And based on this particular situation, we are required to calculate tension in the string, but not in any string. We are required to calculate tension on the sixth string from the top. So if this was the first string, this was the second string, we move on and we get our sixth string, that is between block number 5 and block number 6. And this is the tension that we are required to calculate, that is T6. Now, before we get with the solving side of this numerical, there's one point I need to make clear, is that is string के लिए all the masses below this string, below this point, would not behave like individual masses like block 4 or block 3. They would behave like an extended body made up of 5 individual masses. Now we shall discuss this point in more depth in some time. But before that, let's get into the solving side of this particular numerical, starting with the given data. So what do we have? So हमें पता है कि हमें acceleration दिया है of the system. It is an upward acceleration. It's given to us as g by 2 meters per second square. And the second quantity that's been given to us is the total number of mass and strings involved in the string, that in the system, that is 10. And based on this given values, we are required to calculate the tension in the sixth string, that is T6. So let us get into the solution side of this numerical. So for the solution, we have an FBD given to us. And this is the FBD of block number 6, which I said behaves like an extended body. So from this FBD, I can say that all the masses beneath sixth string behaves like an extended body whose total mass capital M is 5m. Okay. So on this block, we can say that there's a tension due to string number 6 acting in the upward direction, T6. And then there's a weight acting due to Earth's gravitational force in the downward direction. And this block itself is at an acceleration g by 2 in the upward direction. So based on this FBD, if I were to write equation, I would get an equation like this, where T6 minus W must be equal to mass into acceleration. So if I were to substitute the given values to us in this particular equation, I would get T6 minus mg, capital Mg, into capital Mg by 2. So if I were to rearrange this equation in all the like terms on one side and all the unknowns on other side, I would get equation in this particular format where we have mg by 2 plus mg. So this is half plus 1. So this becomes 3 by 2. So I can say my tension in the sixth string is 3 by 2 times of capital M into G. Now, the value of capital M is known to us, as we have discussed. It is 5m. So if we substitute that value, we get T6 is equal to 3 by 2 into 5m by g. If we were to solve it further, we get 15 mg by 2. And for the decimal value for this particular instance is 7.5 mg. So this is the value of tension in string number 6, that is 7.5 times of small m into g, which is where m is the mass of individual blocks and g is the acceleration due to gravity. And in terms of statement, we have a statement like this where we say tension in the sixth string is 7.5 mg. And that's it. This was the numerical, pretty easy numerical. If you want the PDF of this particular solution, do check out the description. And with this, I hope this helped you. Thank you.